So now we're ready for the unit circle. Woo woo. So I've gone ahead and written in all the values for my unit circle. And I think we're going to build this in class together, but it is in the OneNote if you need it, or if you just want to go back and look at it or whatever. So in the inner ring, oops, I'll get that out of the way. In the inner ring, I've put all the degreed angles going around my circle from 0 to 360. Oop, except I see that I forgot 180. Let me get 180 in there. In the middle ring, I labeled those same angles, but in radians. So from 0 to 2 pi, so we can see the relationship of the angles. And then in the outer ring, I actually put in the ordered pairs from all the points going around the circle. Remember, as a unit circle, we're just saying that the radius of the circle is 1. So if we go 1 unit, or if we go straight north at 90 degrees or pi over 2, that's 1 unit away, so that would be 0, 1. 1 unit out to the left, whichever way left is, would be -1, 0, etc. Okay. Yes, I'm going to expect you to know this, but hopefully you can see that there's a lot of relationships built into this circle. Like, take a look at all your pi over 6 angles, all the angles that have a reference angle of 30. If I follow those out, I'm seeing an ordered pair of root 3 over 2. If I go to the second quadrant, the ordered pair is root 3 over 2, 1/2. The second quadrant is negative root 3 over 2, 1/2. The third quadrant, if I take that pi over 6 angle, is negative root 3 over 2, negative 1/2. And then fourth quadrant is negative or positive root 3 over 2, negative 1/2. So do you see that the ordered pairs are basically all the same? It's just a matter of positives and negatives depending on what quadrant they're in. Okay, so anything with a 30-degree reference angle is that same ordered pair. Same thing with 45. Anytime we're 45 degrees away from the x-axis, so 45 is a reference angle, we're looking at root 2 over 2's. So root 2 over 2, root 2 over 2, negative root 2 over 2, root 2 over 2, etc. It's just the positive, negative changes that depending on the quadrant. Okay, so when I ask you to memorize this or to know these values, really all we need to know is that first quadrant. Because if you know that first quadrant, you know the 30, the 45, the 60, then all of the other quadrants follow suit. Just all we'll have to do is change positives and negatives depending on the quadrant of the angle. Okay, so scroll back down. So when we talk about these numbers, I'm going to get back to a pen. When we talk about these numbers, and we've talked about this before, the x value in a point is the same as the cosine of the angle. That was James Tanton looking out, and that was the overness of the sun, if you remember that video. The y value of the point, the height, was the sine of the angle. So that was the height of the sun. The height of the sun is your sine value. That's y. When we take the ratio of y over x, or sine over cosine, I want to write that in there also, that is the tangent of our angle. Okay, and think back to when you know about the, I was thinking about something else. Tangent is really just a slope. So if you know slope, which is rise over run, that's just y over x, that's tangent. Okay, so let's go ahead and use this. I would like to find each value. So if I'm asking you for a sine or a cos or a tan, for now, we can look at our unit circles, find those values, and fill them in our notes. I'm going to go through some of these now, but then we'll do some in class together. So sine of 45. So if I'm looking for the sine of 45 degrees, that means I want the y value at a 45-degree angle. I'm going to go back to my circle. 45 degrees is this guy right here. The y value is root 2 over 2. So the sine of 45 is just root 2 over 2. I'll make this bigger so we can see it now. Okay, and then we can go to the cosine of 120. So cosine we know is x. 120 degrees is in the second quadrant. Here it is. And the x value for 120 degrees is negative 1/2. So I can just go cosine of 120 is negative 1/2. And then tan of 210 degrees, okay, tangent's y over x. So I'm going to go to 210. My ordered pair was this one right here, which was root 3 over 2, or negative root 3 over 2 and negative 1/2. So for my tangent, I'm going to do the y over the x. So negative 1/2 divided by negative root 3 over 2. Okay, so that's my y over the x. Now you can see it's a little messy, and we are going to clean it up. This is really just a division of fractions. And remember, if you want to divide fractions, you keep the top one the same. We multiply by the reciprocal of the second fraction. So the -1/2 stays, I'm multiplying, and I'm doing the reciprocal of the -√3/2. Do you notice that there's a 2 on the bottom and a 2 on the top? They will cancel out. So it looks like, got a negative times a negative, so a positive, 1/√3. However, we are going to rationalize this. I expect your fractions to be rationalized. No radicals in the denominator, okay? If you leave a radical, I will probably take points off because I'm telling you right now, don't do it. So I want to get the radical out of the denominator. I'm going to multiply both numerator and denominator by √3. So that gives me 1 times √3, which is √3, and then square root 3 times square root 3 just makes 3. So that is the tangent of 210 degrees. Okay, so I'm going to stop with those now. We'll do more in class, but that's the basic gist. If you're looking for sine, you're looking at the y. Cosine, I almost wrote cosine out. Cosine is your x, and tangent is your y over x. All right, let's jump down to starting to think about these values. Okay, so again, I'm not going to do all of these. I just want to go through a couple lines. So instead of memorizing the whole circle, like I said, we can just use our reference angle because the angles that have the same reference angle have the same ordered pair. So if I give you an angle of 330 degrees, first thing I want you to do is think about your reference angle. So how far is 330 degrees away from the x-axis? It's really close to 360, and it is 30 degrees away from the x-axis. Now, to find the sine cos tan, we need to think about a 30-degree angle. So here, I'm going to draw a 30-degree angle. There it is. Hopefully you can see from this that the x value from our 30-degree angle is going to be bigger than the y value, right? It goes over more than it goes up. Now, we have basically 3 options for x's and y's. We're going to have √3/2s, we're going to have 1/2s, and we're going to have √2/2s. The √2/2s are saved for all the 45s. They are √2/2, √2/2. Okay, so if you have a 45-degree angle, be happy because they're √2/2s. So the √3/2s and the 1/2s are what we're going to use for our 30s and our 60s. We just need to remember which one goes first. So in a 30-degree angle, if we are going over farther than we're going up, then the over part, or the cosine, must be √3/2, because that is bigger than the y value, which is our sine. So really what I'm saying here is, and I should have put in a column for this, is that the ordered pair for a 30-degree angle is √3/2, 1/2. Okay, the x value is bigger than the y value when we're talking about any 30-degree angle. So the sine, which is my y, is 1/2. The cosine, which is my x, is √3/2. From there, we can find our tangent because we're going to do the y over the x, the sine over the cosine. And I feel like I just did that a minute ago, right? I did 1/2 over √3/2. 1/2, if I can squeeze this in here. So that turned into, looking back above, √3/3. Okay, so really, you need to know first quadrant angles. You need to know the 30s and the 60s. What side is √3/2? What side is 1/2? And then the 45s or the pi/4s are always √2/2s. Okay, now one last thing on this 330-degree angle. When I go to find the 30-degree, I know everything's positive, but my original problem was 330. So we need to assign some negatives in this problem, right? 330 degrees is in the 4th quadrant. In the 4th quadrant, the y values are negative, which means in the 4th quadrant for a 330, my sine should be negative. Okay, so technically this is no longer the sine of theta prime, this is the sine of theta. That's all I had to do. All I had to do was adjust it to make it a negative value. Let's see if there's anything else I want to hear. Okay, so let's go backwards a little bit. So if the sine of theta is 1/2, find theta. Okay, now remember, all this means is that the y value of an ordered pair is 1/2. I want to know what angle or what angles have a y value that's 1/2. So if y is going to be a positive number, I know I'm going to be in the 1st quadrant and in the 2nd quadrant. Okay, and if the y is a half, that means the x was root 3 over 2. It was bigger. So again, that tells me that I'm not very far off of the x-axis. This is the angle that's closest to the x-axis. This is the angle that has the y value that's the smallest. So it's a 30-degree angle. So in my first quadrant, I can say that theta is 30 degrees. Now, going to the second quadrant, that 30 degrees is my reference angle. So if I'm going to measure that second quadrant angle that has a reference angle of 30, if I'm 30 away from 180, my second quadrant angle must be 150. All right, and then again, we'll go through the next one together in class. I think that's it. So the unit circle is helpful because it tells us ordered pairs of special angles. But again, there's really just three you need to know: 30, 45, and 60. Now, with that being said, excuse me, you do need to know like 0 degrees and 90 degrees and 180 degrees. But I would hope those are the easiest ones because those are all ones and zeros, right? At 0 degrees, we're just straight out 1 unit, so it's 1, 0. At 90 degrees, we're straight up 1 unit, so it's 0, 1, that kind of thing. So first quadrant and any quadrantal angle is what we will need to know in order to really know this unit circle.